This is PreCalculus 12, Chapter 6.5. We're going to be looking at the characteristics of trigonometric functions. And we've already learned scaling, horizontal and vertical, translating, horizontal and vertical. But now we have to learn some new terminology because trigonometric functions are used in physics, engineering, electronics, signal processing, lots of different applications, and they have different terminology. So period, we've already learned this one. This is the length, usually a time or an angle, for a function to repeat itself. Cycle. This is the interval from one point to the next point where the function begins to repeat itself. Centerline. This is the line between the minimum and maximum of the trig function. We can calculate it by maximum value plus minimum value divided by 2. It's also called the average. The amplitude. This is the distance above or below the center line of the periodic function. Also, it's another term for a vertical scale. Then we have phase shift. This is another term for horizontal shift. And sinusoidal function. This can be sine or cosine, but not tangent. And frequency. Although we won't be using it in this course, you should know the definition. This is the number of cycles per unit of time. So for example, hertz is the number of cycles per second, and this is how we measure the frequency of sound. Okay, and the general form is A, f of b, bracket x minus c, bracket, bracket, plus d. And we're used to seeing this as c, d, h, and k. We've seen a and b before as well, but we don't say h or k, we just say c and d. So, determining the amplitude. We go from the center line to the maximum. And that's this function, and a equals 2. And we can use this only if it's a sinusoidal function. It doesn't work for tangent. So a equals max minus the center line, or we can do the difference between the max and the min and divide it by 2. So for instance, we can do this calculation. 1 minus negative 1 divided by 2. This is 1 plus 1 divided by 2, and that's equal to 1. And again, if a is greater than 1, the absolute value, this is a stretch. The absolute value of a is less than 1. This is a compression. Next, determining the period. That's using b. So the period equals pi over 2. We can look at the cycle here from here to here. This is pi over 2, and this is negative pi over 2. Negative pi over 2. And we get the period here as pi. We can also calculate the period. It's 2 pi over b, and that's 2 pi over 2, and that's pi. And we have b here is equal to 2. And if we look at our regular function, we can take a point there and point there because those are on units that are easy to see. Period equals 3 pi minus pi, and that's 2 pi. And again, period can also equal 2 pi over b, that's 2 pi over 1, and that's 2 pi. b equals 1. So we can measure the graph, or we can use analytical calculations, and we already went over this, 2 pi over b, provided that b is greater than 0. And we can also calculate b as 2 pi over the period. Now, if we're doing tangent, the period is pi over b. Again, b must be greater than 0. And we can calculate b as pi over the period. So again, use this one for sine or cosine. Use this one when it's tangent. Next, determining the phase shift. We have the form y is equal to f of x minus c, where f can be sine, cosine, or tangent. And we have the base function sine x. And here we are looking at the red one, and we want to determine what the phase shift is. We have to go from the center line going up to the center line going up. And this is pi over 4. Now, some people have trouble calculating this. We look at pi and we go 1, 2, 3, 4 units. So every grid unit is just pi over 4. So we just count the number of grid units and do pi over the number of grid units. So y equals sine x minus pi over 4. And c is just pi over 4. Remember, it's minus c, so we don't use that minus sign. If c is greater than 0, we're going to the right. If c is less than 0, we're going left. And always measure c from a point on the y-axis, so the y-intercept. If it's cosine, we'd start from 1 and measure how far we're moving the cosine. We're moving the y-intercept. So if we were using cosine, the phase shift would be pi over 2. Next, determining the vertical shift. Again, we would call this center line. Y is equal to fx plus d. And if d is greater than 0, it's up. And if d is less than 0, it's down. And always measure d from a point on the x-axis. So if we were going back up to this example, this is our center line. And if this was moved up, we'd measure from center line to the center line of the new function. Don't try to measure from peak to peak because there could be an amplitude change as well. For instance, if we did a sinusoidal curve up to there and came down, we'd have to measure the center line here, and we're moving up 1/2. And that completes this lesson.